Principal Sheet. Welcome back to our classroom. Today, we'll be learning about Hooke's law. Extension is proportional to force, according to Hooke. The history of this law is, in 1676, a man named Robert Hooke discovered that the extension of a stretched wire is proportional to the force applied, or the weight of the object being hung. The arrow points to the natural length, and another arrow pointing to the red line is pointing to the extension. The length of an object that is not stretched is called its natural length. For example, if a metal wire is supported at the top and a weight is attached to it at the bottom, it will stretch. The law stops once the force is too great. There's a limit to the amount of force that can be applied until the law is no longer true. The first part of the graph shows that Hooke's law is being obeyed. However, once the force becomes too powerful, the graph starts to curve. The point called A on the graph marks the elastic limit. If the force exceeds the elastic limit, the material will be permanently stretched. So even once all the weight or force is removed, the material will be longer than the natural length that it was before. Now I'll teach you how to investigate this phenomenon. Set up an apparatus as shown. Get a weighted stand, a clamp, a spring, a few weights, and attach the spring to the clamp as shown. After properly set up, make sure you have extra weights and the apparatus is on a flat, solid surface, because if it's not on a flat, solid surface, then it could topple over and it will hurt your feet if it lands on them. Measure the length of the spring when there are no weights on it, so that you know the natural length. Add one weight at a time, making sure that the spring comes to rest before measuring it. Remember, the extension is the difference between the natural length and the length it becomes once you add the weight. Repeat 3 to 4 until you have collected enough data. Once you have finished this, repeat again so you can calculate an average value of length of the spring for every applied weight. If you want to do some more, make a graph of your results. The force should be on the vertical axis and the extension on the horizontal axis. You should see that the same increase in weight will result in the same increase in extension. Maybe do all of this again, but with a different spring type, maybe a rubber band or a metal wire, and see which variable extends further. I'll give you a few questions to test your understanding. What is the full name of the person who made this law? The full name. What happens if you increase the force past the elastic limit? How do you find the length of the extension? What is the length of an object that is not stretched yet called? The answers are Robert Hooke. The material will be permanently stretched. The length of material with weight/force minus the natural length. And that is it for today's video. Please like and subscribe if you learned something new. 3, 2, 1.